Hey guys, so today we are going to talk about putting everything we know about inverses together, and we're going to graph them on a single graph. So we have our original equation, a natural log of x minus 2 plus 4, and so the first thing we're going to do is to find our inverse algebraically. So first of all, we need to go ahead and rewrite with y. So we got y is natural log of x minus 2 plus 4. And then we're going to switch our x and our y. And then we need to solve for y. So we're going to go ahead and subtract 4. And now we have the log isolated. So now, remember, if it's natural log, the base is e. So my base is going to be e. My exponent is going to be the x minus 4. And it's going to equal y minus 2. So e to the x minus 4 equals y minus 2. And then we need to get rid of the minus 2, so we're going to add 2. So it's going to be y equals e to the x minus 4 and then plus 2. So that is my inverse. So my inverse, I'm going to just rewrite it here. It's going to be here. And then my function was the natural log. Okay, so to explain the process for finding the inverse, we're just going to say the steps. So the first step was replace f of x with y. Switch x and y. And then we solve for y. And then really we rewrote with the function notation. Okay? So we're going to take that and we are going to make tables representing both of those. So today we're going to talk about graphing those. So our original function was the natural log of x minus 2 plus 4. Yep. And then our inverse function is e to the x minus 4 plus 2. All right, so we're going to use our calculator and our table button, and we're going to put in natural log of x minus 2 plus 4, and we're going to get a table. So our asymptote is going to be at 2. All right, so the asymptote of f of x is going to be at x equals 2. And then we've got 3, 4 that we can use. And hopefully we have something else. Nope. Well, that's going to be fun. All right, no other points, so that's fun. All right, and then if we're going to write a table for e to the x minus 4, and then plus 2. Let's see what we have there. All right, our asymptote here is going to be y equals 2. We have 4, 3. All right, this is going to be fun. All right, so when we compare the original table to the table of the inverse, there's not really much to compare here. Here we have the original is 3, 4, and the over here we have 4, 3, right? So we switched the x and y. All right, and so what we should see here, and this is going to be interesting, x plus 2. So I'm gonna graph this in 2 different colors. So I'm gonna do x plus 2, and then the only point I have is 3, 4. That's lovely. All right, and then the other one is y equals 2. And that graph is going to be 4, 3. 1, 2, 3. All right, so if we remember correctly, my exponent graph is going to look like this, and my logarithm graph is going to look like this. So I'm going to do, ooh, that's not good, something like that. And then for my log, and then, whoa, something like that for my exponent. All right, what we should see is that if I draw, and this may or may not work out very well, if I draw this line, y equals x, oh yeah, that worked, okay. If I draw y equals x, I should see that those 2 lines are reflected. All right, so they reflect over y equals x. That doesn't look too bad. All right, and then the asymptote of the original function to the inverse is the same number, different letter. I'm sure that's not the mathematical way to say it, but all right, so we had x equals 2, and then the inverse was y equals 2. And it would have switched had we gone the other direction. So for the logarithm, the domain of f of x, so domain is your x values, and the range is your y values. So on your logarithm graph, which is the green one, the domain starts at 2 and goes to infinity. So the domain is 2 to infinity. And then the range is going to be negative infinity to positive infinity, because it goes everywhere up and down. Whereas the domain of the exponential graph, right, the domain is all x's, right? So negative infinity to positive infinity, or all real numbers, or the little funky r. And then the range should match the domain of the log, so 2 to infinity. All right, so compare the domain and range of the original function to the domain and the range of its inverse. So they're inverses, or they're opposites. All right, and then show the 2 equations are inverses by using composition of functions. So our inverse function, we said, was e to the x minus 4 plus 2. So e in our original equation was natural log of x minus 2 plus 4. And then minus 4 plus 2. And my e and my natural logs cancel. My plus 4 and my minus 4 cancel. And then when I bring down my x minus 2 plus 2, my minus 2 and plus 2 cancel. So I'm left with y equals x. And that is everything. That's all the things about inverses. So if you have any questions, just let me know, and we're going to try a few examples of this.